Hello, pre-calculus class. Today we are going to look at how to find the equation of a sinusoidal graph when I'm given the graph or some data points or at least a part of the graph here. So we have this graph below that I've tried to sketch out relatively accurately. It's got a specific scale here. I'd say pause the video for a moment and try to sketch this in as accurately as you can, right? Take note of kind of these important points. The important points of a graph, right? Always the high, middle, and low points, making sure that they land in the right, like X, Y locations. So you have one pretty solid example of what this would look like. So take a minute, pause the video now, get this in your notes, and then we'll talk about how do I find the equation of it. All right, to get the equation of this graph, we're trying to make it look like that kind of general transformed where you had this, right, y equals c plus a times whatever the trig function was, right, either cosine or sine of b times theta minus d. And we're looking for, like, what are these four constraints on this, right? Because there are four possible things that I could change in here, right? And all of those four things are coming from kind of the four main features of this graph: the sinusoidal axis, the amplitude, the period, and the phase displacement. So for this, we really want to find out, right? We want to find the equation right? We need to first find, well, what are these features of the graph? So first find the sinusoidal axis, the amplitude, those are my vertical features, say the period, and then the phase displacement. So let's look at those things, right? Well, I have my sinusoidal axis for this graph is at this midline here that I've got right here halfway above the top and the bottom of this graph at y equals -4. Right? That sinusoidal axis is my vertical shift, right? Normally a cosine function or a sine function oscillates, kind of like goes above and below just the line y equals 0, the x-axis. But now we've shifted this thing down 4. So that's my sinusoidal axis, which is this c value up here. I've got that the c value in the equation will be -4. Everything's being shifted down 4 there. Right. The next thing I need to find is the amplitude. Right. The amplitude defined as the distance, right, between the midline and the top of the graph, or the midline and the bottom of the graph. The amplitude is not the whole height of the graph, it is only half of the height. So if I'm going from here at -4 up to the top of the graph at 4, my amplitude is 8 units tall. So that is my a value, right? Normally the parent cosine function goes only 1 unit above or below that midline. Now we're stretching that up by a factor of 8. So I have this 8 as my amplitude out in the front there. Right. The period. Right. The period of my graph is the distance it takes to complete a full cycle. So again, from that you can look from top to top, or bottom to bottom, or midpoint to midpoint, but make sure that you're skipping, right? It has to be the whole cycle here. So I think easiest to go from kind of here to here to get my period. It starts at -15 all the way to 45. That's taking 60 degrees to complete. So my period is 60 degrees here. And we'll just set that aside, right? We know the period is not the same as the b value, so I'm not just putting 60 in here. But my period and the b value, this like that thing that's related to the dilation factor, are tied together. So we kind of know, right, this is going to affect the b but we're going to come back to what that will be. Right? The last one is kind of the trickiest one when you're talking about finding this phase displacement, because it is different for depending on which graph I'm looking for. Am I looking for a cosine equation or a sine equation? Right? So we have two different phase displacements that are possible here, and actually we have more than two. We have an infinite number of potential phase displacements. Because this thing is periodic, I can define its starting point to kind of be wherever I want it to be. So if I'm looking at the phase displacement, though, usually we want to identify a phase displacement that's A, in the range of what we're given, right? And B, right, try to make it kind of close to this 0 spot here. So we're going to have different phase displacements. This will be finding the D value, right, for sine and cosine separately, right? So for my sine function, the phase displacement is always starting at the midline on its way up. Right? A normal sine function, if you graph the parent sine function, it starts at like 0, 0, and then as the angle increases, it starts to go up from there. So right, I have that parent sine function that's increasing. Right? So I want to find one that's at the midline going up for my phase displacement. And I have two different locations for that. I could either shift this thing left 30, right, or out to the right 30, right? Either one would work. So I could say I want to shift this thing out positive 30 degrees. That would be going right 30. Or I could say, right, I wanted to move this thing backwards, left 30, right? Would start me here. Both of those will start my sine function at the middle on the way up. Right? Cosines are a little easier. They always start at the top. Right? So where are my top points? Right? I have one that's negative, but it's a little closer to 0. And then I have one that's positive that's a little bit further away. We could identify either one of these. I could say, right, let's move this thing 15 degrees to the left. Right? Normally it would start here, but if we shift it left 15, right, that would make this graph start at negative 15, or I could go positive 45. Right? Both of these are possible ones, and really every 60 degrees after that. I could shift this out 115 degrees. Nope, 105 degrees. Right. 165 degrees, 100, and I can kind of keep going out from there. So now I'm really close to finding these equations, right? I've got my C value is set as 4. I have my A value is set at 8. My D value, I have a few different possibilities, and these are like specifically the D values. The only thing we need to find still is what is this B value in here. We know the period, but we need to find what's the actual number that's going in this function that will give me this graph. Because if I plug in 60 there, it's not going to give me this graph at all. So we need to find the B value to create the equation is our last piece here. Right. We find the B value from the period. To create the equation. So I know from last time, this is very formulaic. My B value is just equal to 360 divided by the period. So I have my period. My B value is 360 divided by 60, which just gives me 6. So that's my B. I have all 4 things, A, B, C, and D. So now let's make our equations here. I asked for 2, 1 sine, 1 cosine. So let's do my sine function first. I'm going to have y equals, it's always c plus a times the sine of b times theta minus d. My c value was -4. Plus my a value is 8. I'm doing the sine function of my b value is 6. And it's going to be theta minus the phase displacement. So I could do theta minus 30 here. Would be one equation. For cosine, there's only one change that I need to make, right? The sinusoidal axis has not changed. The amplitude has not changed. The trig function has changed, right? Like I'm changing from sine to cosine now. My period doesn't change, so that b value, right, does not change at all. The only thing I need to worry about is now, right, it has a different phase displacement. So the phase displacement for cosine we said was left 15. So it'd be minus -15, which we usually write as, right, that double negative as a positive. And there's my equations, right? Note, I could have used these phase displacements, right? I could have done minus -30 or plus 30 for sine, would have given you the exact same equation. Could have done minus 45 here instead of plus 15, would have given me the exact same equation. There isn't a right or wrong answer for that. There's just an infinite number of right answers. There's also an infinite number of wrong answers, right? Like it has to be in these multiples like 60 degrees apart from each other. But those are just my two possibilities here. So there you have the general way of finding, right, these equations. Again, always looking for what's the sinusoidal axis, what's the amplitude, find your period to help find that b value, and then for the different types of functions, look for the possible phase displacements. Cosines starting at the maximums, right? Sines starting at the middle on the way up, right? And so I have these graphed here, right? So here is one of our potential equations, right? -4 plus 8 times 6 times cosine of 6 times x plus 15, right? Gives me these same high, middle, and low points, right? I should maybe graph, right? Like this is my sinusoidal axis hitting at these specific locations, right there. So it's a good way that you can check. And all of these, right? This will give the exact same equation as well, right? That gives the exact same equation. I might give a bonus. There is a way that I can write this with no phase displacement whatsoever, right? So I have this one graphed here that has no displacement as a sine graph. That you kind of notice it does start at the midline on the way up here, but it's this mirror image of the one that I'm actually trying to get, right? Like the green now is the one that we were trying to get. This one is close, but it's a reflection of it. Hopefully you remember from first semester, but if you have a negative sign out in front of that function, like if you do g of x equals negative f of x, that reflects it across the y-axis. So if this was a negative here, right? So -8 sine of x and then shifted down 4, I can have, it doesn't make the amplitude negative, but it makes the dilation factor negative, that vertical dilation factor. So if you were looking to, right, find the actual one that was the closest to that y-axis, sometimes you can achieve that by making that vertical dilation factor negative, which flips the graph, right? So just that change from the positive to negative, right, flips my graph upside down and achieves what I'm trying to get there. So there you go. You have all of that. There's a few questions in the book to practice. Let me know if you have questions in the chat.